This is eHobbyist blog, a log of electronics hobbyist activities aimed at city dwellers who have limited space, limited money, and limited time. My name is Neil. Welcome. During this video, we will breadboard a prototype positive power supply as previously diagrammed. I'm going to start this breadboarding operation by gathering all of the components together, tacking them down to a piece of paper, and recording the labels corresponding to the circuit diagram. First components, R1 and R4, are 18K. They make up a voltage divider along with R2 and R5. Voltage divider is applied to the inverting and non-inverting inputs to the differential amplifier of the 723. R3 is 2.5K pot that allows the adjustable voltage. R6 is leakage limiting, allows the operation of Q1. R7 is supposed to limit the output of the 723 to 10 milliamps. R8 and R9 I've made some changes to, although I try to stick to the published diagram. R8 is going to be 0.62 ohm resistors, current limiting to 1 amp rather than 2 as indicated. And R9, I couldn't find a 100K resistor, so I'm using a 120K resistor. C3 is the 100 microfarad output capacitor. Now I'm going to test these passive components. Just because something says it's a 18K resistor doesn't mean that it actually is. First one we get is 17.57, about 2% off. Next is 17.67, also about 2% down from 18K. That's well within the spec. Now 54K, that's a little bit high. It's 6% above that specified. And same for 54.1. The pot is at 2.560, which is right on, within 2%. R6 is at 46.3, well within spec, at 2% down. R7 is 1.83, and that's fine. I can't really test the R8 resistors. R9 is measured at 119, which is high. It's about 90% over what I would like to see it at, but I just didn't have the right value of resistor. Capacitor C3, it takes a while to clock up the capacitor. But this particular capacitor is coming in at 156.5 microfarads. It's high, but it's an output capacitor, and being high is okay. The compensation capacitor should be 470 picofarads. It's coming up at 460, 2% down. What I'm going to do is attach the output of the rectifier filter module for 0 to 20 volt supply to the binding posts, and in so doing attach it to the corresponding power distribution strips. I'm attaching a spade lug to the rectifier filter's output. Let me tighten these things up again. They will be also attached to the horizontal power distribution strips and make breadboarding a bit easier. I want to test the connection, make sure I have some voltage in there. connect AC power, and using a digital multimeter, test the voltage of the binding post. Coming out at 28.76 volts. I'm starting off 723 IC. Pin 1 of the IC is at row 31. Now we connected a jumper to the plus and minus, now corresponding to the input to the voltage regulator. Connecting the power to pin 12 and negative to pin 7 of the IC. And connecting a negative to the output zener. Now I'm putting the frequency compensation capacitor in and connecting that to pin 13 of the IC, the other end of the capacitor to the inverting input at pin 4. Looking to install R1, which is part of a voltage divider along the non-inverting input. R2 is in place. I'm making provision for connection to the pot by having this orange lead sticking out, and the gray one, and the brown one. Basically, these will be the connections for R3, and let me just temporarily connect those up. I didn't have a breadboardable 2.5K pot, so I'm just connecting with stick-out jumper wires and alligator clips. Now connecting R4. And R5 is going to make the second voltage divider hooked into the inverting input. And Q1, the output power transistor, 2N3055. The emitter is being connected to another vertical distribution strip, so that one has adjacent vertical distribution strips, power input, ground, and power output. Connecting the collector of the transistor. Connecting R6. Well, it looks like R6. I don't know. I thought it was R6. Okay, now we're connecting up the base of a power transistor to R6, green wire, and the output, the emitter of the power transistor, just making provision for hooking that up later. Now his is Q2, 2905, and positive power to it. This is R7, following along on the schematic. You'll notice I'm trying to get rid of some of the corrosion on these leads. These are old components. R9, we're supposed to be maintaining the Zener regulation. Now connecting the base of Q2. Another power connection to Q3, and this shunt resistor, which is going to establish current limiting, R8. And power output capacitor, one side of which is connected to ground, the other side to power output. And connect the pot here. There's a silicone alligator clip, so kind of slippery. And we have a circuit. Now, against my better judgment, I'm going to do some preliminary tests on this breadboarded circuit. Just turn the power on. I've got my 28 volts coming in. I'm going to change leads on the DMM and connect negative lead to the negative power coming in to the regulator. And positive is being connected to the output. Now I'm going to fiddle around with the pot, and at one end of the pot I am getting 21 point whatever 5 volts. And this circuit is behaving like it's an adjustable regulator. However, going to the extreme opposite end of the pot range, I'm not getting down to 0, which is a problem. The circuit kind of half works. In this video, I gathered the components needed to breadboard the circuit, measured the values of the passive components, temporarily connected an output of the rectifier-filter module to the system binding posts, breadboarded the circuit, and did a quick test of the prototype. Based upon preliminary testing, the breadboarded circuit behaved like an adjustable power supply, but did not go down to 0 volts. In the next video, I will be troubleshooting the prototype. If you like this video and the idea of the channel, click on the YouTube thumbs up icon. If you want to be notified as to when the next video is available, click on the YouTube subscribe button. If you want to suggest future directions or topics, make corrections to published videos, or voice your opinion on related matters, then leave a YouTube comment. If you want to see supplementary material that cannot be easily presented in video form, such as high-res graphics, files in different formats, lists of references, go to the corresponding website. Until the next time, good day.